what we are going to talk today is related to the simulator of the Arduino board and how we can simulate it. As we talked last lecture, all the time it's not possible to have all the variety of the sensors. All the time you cannot test on the real hardware. Even now I know that you receive the board from school, and school help us more for these lectures. Now you have the board, but the main thing is that somehow we need the simulator before seeing the real action on the board. And as much as this simulator have the accurate uh, behavior, we can be sure that our codes on the real environment are also working well. Then one of the recent simulator which come to pictures, especially for the Arduino, is TinkerCAD, which due to its fantastic GUI and nice environment, which is more like the real environment, it's preferred by the Arduino users nowadays, and even it's very recent things in Arduino world which we decide to review today. Then today, first we will talk about Arduino simulation using this TinkerCAD. Then we will review some ID important part and what are the difference between the extension 5, which it will be discussed in the second lecture of today. Then mainly first lecture we will talk on TinkerCAD with some samples and some description that how we can use it with the Arduino board. Well, let us start about this point that what is the TinkerCAD. TinkerCAD, first of all, it's free. Second point is that it's online 3D modeling program that it will run in a web browser known for its simplicity and ease of use. Since this concept or this environment generated in 2011, it has become more popular between the users, and specifically for the creating the 3D printing model as well as every level introduction to constructive solid geometry in school. The owner of this software is AutoCAD that we work lots of the time with the Photoshop and other product expansion to include the circuits in its design capability, which they call it TinkerCAD Circuits. This new concept brings the whole new sides to the TinkerCAD and revolving around the simulating circuits with Arduino. They generate this simulation first for the 3D modeling, but now they extend it up to the electronic circuits, and mainly they focus on the Arduino microcontrollers board or Arduino concept. And as you see and we discussed in our lectures, that Arduino is an open source electronic prototyping platform that also sells microcontrollers, and TinkerCAD Circuits allowed anyone to virtually create and program Arduino project without the need of physical hardware, which is one great things inside for the TinkerCAD. Inside TinkerCAD is simple. With the 3D environment that it has, it will eager people to use it. And our work is here that how we can show to you to work. I can show that how you work with this. If we want to follow the instruction which is introduced by TinkerCAD website, they say that this software will offers many benefits like online that you don't need to do any installation and anything in your PC. Means that no need to specify the much more space from your systems. It's open source, no license needed for everyone, and the simulator offers the good interface for designing and simulate the project, and it's better than FreeThink. FreeThink is also very nice, but now I recently have some news about TinkerCAD variety of the work, which people use it more, and they give the lots of good reports about it. And you know that, but the little problem is here is that the lack of package and components that we had in freezing, somehow they try to extend, and it becomes much more better in future. What we can do with this TinkerCAD and what do circuits add to TinkerCAD is the other topics that I want to talk with you. You know that TinkerCAD has also introduced some extra combination with these two boards. You know, CAD environments new come with circuit components models, which both of them will be beneficial for the users. Means that you can have somehow some integration between previous CAD and these now circuits that you have. This means that you can design the model with the circuits and hardware, and once 3D printer, the circuits can be easily placed with the creation. Something like integration of creation between electronic and circuits parts, and also some mechanical or some hardware design can be simply do with this. As it's mentioned before, and we also talked, TinkerCAD open up the possibility of electronic functionality in the 3D printer also. And to that end, in the user's dashboard, you can find the whole section devoted to circuits project. It's organized similarly to CAD project gallery, and make it easy to navigate. Suppose you can also find the circuits in gallery parts of or learn parts of the TinkerCAD webpage and follow the instruction that they give. But what we have in design suites of the electronic part, it's something like this. As you can see, lots of sensors are there, something like PIR sensors. It's great. LED bars, LED sections, Arduino boards, some oscilloscope, fantastic, some gas sensors, some LDR, some FR, means that force sensors, some thermal sensors, LED, buzzers, batteries, motors, great, LCD. I can tell you, and keyboard and switch. I can tell you more than what we need for our course. You can easily get from this. And once you decide to create the circuits, you will be using the new TinkerCAD circuits environment. Lots of ICs, lots of things which integrated there make this simulator more popular than other ones. Let us see what is the environment. First, before logging inside the TinkerCAD environment, I will show you some screen from my login page. And then after this part, we will see some demo, how to log in and how personally I log in and enter to this web page. As you can see here, after logging inside the web page, you have these parts. First is, we can start from here, suppose. This is the name of your project that you can rename whatever you want. These are some editing tools that you have, and you can work with them, something like do the rotation for the components, some deleting, some undo, redo, some notation that you want, some option like this that you want to make it visible or invisible. It's also possible, which is great. Here at the top here, you will see your profile that you can make it and introduce yourself to others. Suppose you are a teacher or you are a student. It's great. It will help you for some scientific connection or some scientific thought with the others. And in the below this part, you have one nice part that we call it programming situation, which in that there is 4 parts. One is that code that we will discuss, a start and a stop simulation. After you finish your job, you can do that. And some export, which you can export your you can export your design part, and even you can share it in the gallery. And share is that share is for the gallery, and export is that when you want to save the result of performance. I have done that. We will see some PNG picture will be generated from your design, and you can have the feel of exactly 3D modeling. This environment, I can tell you, it's very fantastic. And even when I work, we have the feel that we work really with the hardware. Try to means that have this concept that this is simulator, and before that, like the 3D we had for FreeSync, we had for Pro Tools, but not this much sensible components. And if you want to select the components below the programming part, programming tab, you can see the components which are arranged very nicely, and you can select them. This is what you can see in the first page of the components, and then what the parts are look like. Maybe some of you will ask me how we can enter. Very simple. I give you the URL here that with tinkercad.com. Simply you can access to this webpage. Let us see more about the parts. Suppose the components part, which is more important for us, and we should focus on that more. It's the one part that even I bring some photo here for you that you can see. It's on the right side of your screen, and you will see the group of drag and drop electronic components. On top, you can reach and filter through an impressive number of available components, and there is everything from LEDs to integrated circuits, ICs, and even a few instrument tools you can find. Something is there that there is one tab, that if you put that tab, it will show you the component with some description, maybe some in principle of them and name of these components will help you to have more detail about this concept. The next part, that I call it building area. This is the open building area here. That is where you design your creation, and you can just drag and take the components and put it there. This is the environment that you can, this is your work, and you can work in that. Next part is the programming. Now for programming, I should tell you that in the recent years, what they have done, there is one new concept that we call it block diagramming, or they call it scratch programming. This scratch programming mainly built for the undergraduate and even 12 standard or 9 years old group of the students that they are interested to do the coding, but they are not familiar with the coding syntax. Now what they have done, for them, they made this block diagramming that just after picking the blocks, you can integrate them and do the programming. But what nice thing they have done in Tinker, along with this scratch programming, they put the text file for us that we want to do it with C++ here. And beside, they have done blocks and text that you can even convert. You can write into text and also receiving the blocks and something like that. What we will work, we just working with the text part, because block is not proper for your stage. It's good for, I can say for some very intermediate level of programming, it's good. But for university level, the text is quite fine, and you can do the same texting here. Okay, maybe you ask me which type of text we can add. Exactly what you will do in Arduino IDE, you can copy paste here and enjoy the program. Okay, once you have a programmer components in your design, you can open the code viewer by clicking on the bottom at the top right of the toolbar and start the programming for that. Let us see more about this programming that currently for the programming part, just Arduino and ATTNI is okay, but Arduino R3. And as you know, ATTNI is more limited and miniaturized Arduino, and the programming area is a simplified integrated development environment, something like IDE that makes programming the Arduino very straightforward. The default method is via the code blocks, and which we will look at later. And there is also a dual viewer for learning how the code blocks translate to the actual code, which is the one nice and fantastic part that the designer of TinkerCAD made on that. Some more option we have when we want to work with the TinkerCAD environment. It's something like that we call it top toolbar. Starting on the left gives you the general operation to rotate, to delete, and even make notes on your different components that we have the icon here, just we can work with them. And a cool feature is that in addition to exporting and sharing your work, you can download the components list. This makes it easier to bring your creation into the real world. Here I show that components list that you can select from here, or code, start simulation, export, and shape part. Okay, that was the environment for the TinkerCAD. But really, how to get started with this nice simulator? This is this part that we are going to discuss. If we want to touch on about this web page, simply we can enter to the tinkercad.com, and after you have signed up and activate your account, you should see the screen similar to the one thing that I bring here, and click it where it says the 3D in the top left of the work area to toggle to the circuit design. Let us see the next picture. Here you can see the join now or sign in, and then with the sign in part here you can interface this screen. Through this you can enter your AutoCAD account, your Gmail account, your sign in with Apple, or any other email that you have. Students also can enter their students account. If suppose like me you open with the Gmail account, it's something like this, or if you do with the AutoCAD account, you have this environment that you can log in and make the environment based on that. After suppose I enter with my Gmail account, it's need the user is fixed, suppose you will select, and then password you will set, and then very simply you will enter to this environment. But now this is my profile, and this is the part that you can see here, and we will going to talk about this part. Let us see what we have here. Here we have my profile, 3D design, which we are not working with that, circuits, code blocks that we are not working with that, with circuits we are working, and lesson with just right now we don't need. Then very straightforward command is that we are going to add what we can say a click on the circuits part and enter to our web page. Besides, if you want to make your profile proper, you can add your pictures like me. You can give some full name, some email address, and some letter about yourself here that other people can do. This from account setting part. And if you want again to see what we have inside the TinkerCAD, we have one gallery part which it's split into designs and circuits. In the circuits, you will see various designs that people have done before you. You can even simply enter to that and enjoy their design or use in your application part. Let us then see, after selecting the parts that we need, I mean the circuits part, this screen will open for you that you should create the new circuit. And then with these new circuits, you can enter. Let us see the first tour inside the TinkerCAD, and you will see here what I have done. Suppose it's live demonstration that I enter with my email address. It takes a little bit time, depend on your net service. It's not a very lengthy process. It's even short, I can tell you. Yes, it will take some time. It will open the desk for you. This is your desk now, or dashboard part for you. Now this is the account setting and personal information that I already add in that. If you click the upper side, we just working with the circuits parts. With code blocks and lessons, we are not working. Even you can take some tutorial from that, which is nice. You can review that points also. And as you can see, even you can arrange some class inside of this TinkerCAD for your, I don't know, your students. Maybe you can also add there. But now we are not planned like that. For the gallery, we have two parts. One is the design and the other part is the circuit part, which we are working with the circuit parts. And in these circuit parts, you can see the lots of projects that people have done with the help of Arduino. It's great, it's totally in the 3D format, and you can watch lots of design that people have done. Suppose if you select one, you can see the code as well as hardware. And if you want to do the modification, simply you can modify and also change. Even we have some part which we call it how to learn Tinker, and there are some tutorial inside of that you can see them and work and study some lessons, project, and some start initial data. But we are not working with all. We just want this circuits part, which is very simple, and you can follow my illustration and do it. That was again the teach part, and which you can use for the 3D design. For circuits even, we have some teaching parts. Suppose if you are searching for some specific project, something like sensor inside of TinkerCAD, simply you can add and type the name at the top. Then they are going to search it and find it for you. You can use them. And also if you want to log out, simply you can do the log out and then finish this part. That was a small tour about TinkerCAD. Now let us see how we can enter. The first step to enter the TinkerCAD, as I showed you, is creating the account. If you don't already have a TinkerCAD account, you can create simply, and then it will permit you to enter. Next step is that go to TinkerCAD Circuits, click on the circuits to switch from 3D design to circuit from the top, from here I mean, and then click on the create new circuits here. And if everything is all right, we can start the work to discover the platform. Let us see one more demo that what I have done here. I click on create the new circuits, as you can see, and it's going to enter to my dashboard. Then here, as you can see, I have the components on the right side and some other parts that we discussed. Suppose like something like delete, put the notation. This is the programming part, code part, export, share, something like that. And below is the component, but for components, if you finish all your design from here, you can get the list of the components, which is very nice. Okay, and then the next part is the components part that we will go to use some of them, and today we will test the blink with this part. Suppose I want some basic components, something like resistor, that I will take it and put it there. What will be here? Any components have some name that you can call them and change the name and quantity of them. Then it will help you to have the nice BOM when you design. Okay, as you see, that was very simple, just to take the components here and put it on the board. Let us see for the demo 2 what I have done for you. Okay, we enter the TinkerCAD. Simply then you will see some part like rotation, delete, situation. Here, as you can see, we work with the components again. Yes, suppose here we add the battery, some breadboard that you will see the name of them. We can add, we can delete also, very simple. Just select it. And as you can see, if I want to do the wiring, it's not a tough job. Very simple, you can select the node and wire will be ready for you. You can put it. What suppose some mistake I have done there, I entered 2 breadboard that I wanted to remove. Now, one example could be this, that I want to turn on my LED. As you will see, I'm going to change the name of this LED, something like, for the breadboard, I put the breadboard. For LED, I will change the name, and also color I can change to the yellow, as you will see. I put the name for LED as the blinker. Then go down and suppose the value of the resistor we can change. The value of the resistor can be changed. And then, see, I should adjust it proper. See here what I have done. I find some proper place for my LED. Okay, we'll continue. Suppose I want to add some battery. Simply I will select, I will rotate it with the rotate option. Yes, one more, yes. Keep it, put it here, yes. Or just positive and negative part will remain. I'm going to connect. Here I didn't do the proper working part, but as you can see here, when I connect the powers together, Even you can change the color of the LED from blue, red, yellow, and different variety of the color, as you can see here. And as you see, the environment is very nice. It's exactly similar to the real hardware and real lab that we can have. Okay, what about Arduino? Simple. We can also take the Arduino and also connect to this environment, which we are going to talk about this specific practice after some more introduction about this nice software. And whenever I enter some programmable components, something like Arduino, then this code section will be active. Otherwise, if you enter some basic components, it will not come out. And then with the programmable components that I enter inside my environment, you can see the blocks plus text block and text that it's nicely can be mounted for your project or inside your environment. What I feel before that, I thought that maybe in China you have some problem, that I request 2-3 students that they log specifically in China. This is one demo that one of them sent me. Then be sure that 100% you can enter without any problem in China. I'm thanking Roy, my students, that has done that and take this clip for you to be sure that in China also you can enter. Just see how he entered the TinkerCAD. Okay, he put the tinkercads.com and then yes, environment is come up. Actually, I was a little bit worried that you may have problem to enter that. Then before delivering to the talk, I test 2-3 times with some person in China, some of the students in China, that they helped me, and that was great help from them. But now I'm sure that you can also use it perfectly in China and enjoy this product. By the way, suppose Roy now entered there, and also it said that this is the Chinese version even for the this software. Simply he entered there. For the student who don't have the account, they can add the account or sign in there, then sign in. Like this, and then enter. Here, you can copy and tinker, or you can download some, suppose, models, because this student didn't know that what exactly I want. They go for the 3D modeling part, but here you should go for the other, what we can say, other project. Okay, what we learned till now is that what is TinkerCAD, but how we should do the coding based on what we learn. We will see 2-3 projects, but first one is the famous LED brink that I will also put it as your task, and you should repeat these things inside the TinkerCAD. Let us see this project in some steps. The step 1 is that after creating your free Autodesk or any logging method to the TinkerCAD, you will meet with the project selection page that you will select, suppose, circuit. Step 2 is that you will make the create new circuits and enter these parts. Uh, you can create the new circuits, or also you can enter to the existing designer, tinker this to edit your past design. Step number 3 is that you just select the Arduino board and put it in the environment, programming environment, and put it there. If you don't want to start from scratch, there should be some pre-made templates module in the drop-down menu under the Starts Arduino, where it said the components basic. You can also put like that. And for the step 4, which I think it's good, try to have some breadboard like this and make your work easier. Especially this prototyping board or breadboard will help you to have the less error and less problem. You can drag it and put it there, and it's easier than having the floating components, both in real life and also simulation. Then this will help you to have the proper wiring job. Simple. Next step is step number 5, which we needed for the coding part. When you select some programmer component, something like Arduino, then this coding part will be open for you. And then with this part, you can do the coding. Finally, to start the simulation, you can start your simulation part. As I said that, we are not doing this block, we using the text part because it may be better for the university level. And now let us see, suppose if I want to repeat the LED famous blank project, what I need and what should be my environment. Here you can see that if I want to do that project, I need 4 parts. I need one Arduino Uno, LED, some resistor, and breadboard. After you have correctly wired the components, you need to write and upload then the Arduino code. Simply you can paste your code here, and you can also copy paste example, as you know, from Arduino example RD. Let us see one demo I have done here for you. You can see first I log in again. Select the components. And try to connect them together. But what we need is that we need some breadboard that I will bring it here, and then adjust the components. See? Maybe when you start it first, you may have some difficulty to adjust, but it can be removed very fast. Yes, go on. What I decide to put one part for the ground, one part for the VCC, that it will help me to even do the job better. Okay, select the Arduino and then adjust it. But I think if I can rotate this Arduino, then the shape will be better. Then I have done that. See? Yes, I rotate the breadboard, as well as I will rotate the Arduino like this. Well, I need one ground and one signal. Signal can be connected to pin number 12, I think I have done. And ground also can be connected to Arduino ground. Yes. can do it. Even we can do better wiring, but here just I prefer to show you very fast. That is why maybe the shape of wire is not perfect. Okay, I put it now for coding. What should I do? Simply, I will go for code section. I will select the blocks and text or text, no difference. If I put text here, I can enter my code, which is usual and similar to what I teach you in the last lecture. You can put the blinking projector and then start simulation. Okay, something was wrong. What was that? The color maybe is not visible or the place of the LED was not correct. You can simply change it and then run it. Yes. Now you can see that it's blinking. Then the LED is turned on and off, as you can see. Even we can change the ports to 12 or even change the color of LED. Lots of things we can do that you can enjoy later. Okay, very nice. Can we do some more job? Yes, this job I didn't teach you correctly. We will see it in the next lectures. But as an example in Tinker, we can see. Suppose how we can use the serial monitoring, which is very important part in Arduino. We can simply have this one Arduino and one potentiometer that it's connect to my pin number, analog pin number 5. And simply it's there, you can see. Yes. Then we'll go for the demo. You can see that I enter the serial code and even you can have the graph, nice graph inside of Tinker. It's great. It's working based on the code that I written. Maybe this code you will not understand now, but I will teach you for serial communication lectures, and then you can enter it here and enjoy this simulator now. What else we can do? As you see, we had two parts. One was export and another one was share. If you use the export, this could be the output, and if you use the share part, you can see these pictures as the PNG formats or PNG type of the file, which will help you to actually see this program. No doubt, TinkerCAD, there is this TinkerCAD has expanded its additions of the circuit and its many features and possibility of endless. From the suppose components and comprehensive code blocks, there is a lot of things that you can explore and suppose you can see in that. Maybe some of you feel that this data that I shared today, it's maybe it's not enough for you. What I bring that I gave some example from TinkerCAD webpage, which in that we will see.
Let's learn how to blink an LED using Arduino's digital output. If you're new to Arduino, this is a great place to start. You can follow along virtually using TinkerCAD Circuits. Then afterward, grab your Arduino Uno board and a USB cable to create a physical circuit. Take a look at this circuit in the workplane. Click Start Simulation to watch the LED blink. You can use the simulator at any time to test your circuits. The LED's legs are connected to two pins on the Arduino, ground and pin 13. The component between the LED and pin 13 is a resistor, which helps limit the current to prevent the LED from burning itself out. Without it, you get a warning that says the LED may burn out soon. It doesn't matter whether the resistor comes before or after the LED in the circuit, or which way around it goes. The colored stripes indicate the resistor's value, and for this circuit, anywhere from 100 to 1,000 ohms will work great. Click once to connect a wire to a component or pin, and click again to connect the other end. The LED, unlike the resistor, is polarized, which means it only works when the legs are connected a certain way. The positive leg, called the anode, usually has a longer leg and is wired to power, in this case coming from your Arduino's output pin 13. The negative leg, called the cathode, with its shorter leg, connects to ground. Did you notice the small LED flashing on the board itself? This built-in LED is also connected to pin 13 and is meant to be used for testing purposes without the need to connect any external components. It even has its own tiny resistor soldered directly to the surface of the Arduino board. Let's look at the simple code controlling the blink by checking out the code blocks editor. The code starts out with 2 gray comment blocks, which are just notes for us humans to read. The first blue output block sets the built-in LED high, which is Arduino's way of describing on. This output command will activate a 5-volt signal to connect anything connected to the specified pin. Next up is a yellow command block that waits for 1 second, simple enough. So the program will pause while the LED is on for 1 second. Next, after another comment, is a blue output block to set the LED back to low, or off, followed by another second-long pause. Try customizing this code by changing the wait times and clicking Start Simulation. You can even add more output and wait blocks to create longer flashing patterns. In the text editor, you can see the Arduino code generated by the code blocks. All the extra symbols are part of Arduino's syntax, but don't get intimidated. It takes time to learn to write proper code from scratch. I'll break it down for you here, and you can always use the blocks for reference as you level up. This first section is a block comment, followed by the code's setup, which helps set up things your program will need later. It runs once when the program starts up. Our Blink Sketches setup configures pin 13 as an output, which prepares the board to send signals to it rather than listen. The main body of the program is inside the loop. This part of the code will execute on repeat, so long as the board has power. The colored text following double slashes are also comments to help make the program easier to understand. The output command we're using is digital write, which is a function that sets a pin high or low, on or off. To pause the program, we'll use delay, which takes a number of milliseconds. 1 second is 1,000 milliseconds. Try it for yourself in TINKERCAD Circuits. Grab this circuit anytime using the starter available in the Components panel. To program your physical Arduino Uno, copy the code from the window and paste it into an empty Arduino sketch, or click the Download Code button and open the resulting file using your Arduino software. Plug in your USB cable and select your board and port in the Tools menu, and upload the code and watch the LEDs flash with the custom blink you just created earlier. Now that you know how to blink an LED using Arduino's digital output, you're ready to try other Arduino exercises that utilize the digital write function. Try using a breadboard to add more LEDs and code to control them in the next lesson. Thanks for watching and learning how to blink an LED with Arduino and TINKERCAD Circuits. Check out the rest of our huge collection of interactive beginner electronics tutorials and even build circuits into your 3D designs. See you next time.